south of England on a sunny summer's afternoon. An exhibition of tanks and armored vehicles draw the crowds. These military vehicle enthusiasts and a fascinated public take great pleasure from the vehicles of 50 years ago. Fun is had by all, rides are given, and the tanks once more rumble through their paces. In this tranquil setting, it's easy to forget that these machines were once the harbingers of death in the most terrible conflict known to man. The brutal realities of the battlefield can bring out the very worst aspects of human ingenuity. The best minds are used for the worst of purposes, as scientists and engineers strive to dream up new ways to kill, maim, or terrify their enemies, as any small advantage is relentlessly exploited in the desperate search for the vital winning edge. Sometimes fear alone is enough to overcome an enemy. This was certainly the case with flame-throwing tanks. These gruesome weapons had their main tank guns replaced with a flamethrower, which could fire a jet of flame for up to 50 yards. This was not a particularly accurate or even an effective weapon, but both sides used them in World War I. They were designed to be used to winkle infantry out of strong defenses, pillboxes and bunkers, but the main weapon was fear. The flame gun fired an inflammable mixture from a 100-liter tank, which was enough to fire 82-second bursts of flame.
A flame-throwing tank is nothing more than a tank that should resemble a regular tank. And the reason they wanted them to resemble regular tanks is you just don't want to stand out on the battlefield. If you stand out, particularly with you have a full load of jellied gasoline on board, that's not a good thing to have. I guess the most effective use of flame tanks was that used by the United States Marine Corps in the Pacific against the Japanese. The Japanese would get into these reverse slope defenses. They would not come out. You couldn't get them out by any method other than to use the flamethrower. And if you can put that flamethrower behind armor, so much the better.
To the infantrymen crouched in their foxholes, even the smallest tanks project an aura of invincibility. Rolling relentlessly onwards, they seem like an unstoppable armored juggernaut, the very essence of armored might. They appear so invulnerable and impersonal, it's easy to forget that inside the vehicle, there are men just the same as any others, with the same fears and emotions which run through every soldier on the battlefield. In many respects, these emotions are heightened because the tank gives the protection of its armor, but imposes a host of other restrictions on its crew. Inside the tank, visibility is severely limited. The interior is cramped and noisy. The crew are acutely aware that their vehicle is a prime target for every enemy weapon on the battlefield. With their own stocks of fuel and ammunition aboard, they knew that one hit can turn the tank into a blazing inferno. There is also the danger that infantrymen might get close enough to attack with anti-tank weapons from unseen hiding places.
The main sources of danger for tank crews in battle are chiefly the lack of visibility from inside a tank. If you can imagine, you've got narrow vision slits that allow you to see a very small area directly in front of that slit, and you've got a number of those around the vehicle, but there are always blind spots. For most armour of the period, they don't move an awful lot quicker than a man running, and a man running with any sort of anti-tank device is going to be able to outmaneuver you at any phase of the battle.
Under favorable circumstances, placed in good positions with their strong frontal armor facing the enemy, the crews of the German tanks of World War II had good cause for confidence. These Panthers of the later war years could withstand most guns on the battlefield from all but the closest ranges. This is the massive Jagdtiger, which saw action in 1945. It still bears the scars of battle. We can clearly see on this surviving vehicle where Allied shells have hit, but failed to penetrate the armor. Once infantry tank hunting teams got close to the tanks, or enemy tanks were able to maneuver into a position to fire at the weaker sides or rear of the tank, the picture changed dramatically. The all-conquering armored hull could just as soon turn into a steel coffin. The drivers of these American tanks also have a good field of vision, as long as they keep their heads fully exposed outside the vehicle. When the commander stood in the open hatch of his tank, he too enjoyed an excellent view of the battlefield. But when the bullets started to fly, the commander and driver had to retreat inside the vehicle, closing their hatches behind them. Once the tank was battened down, the crew had only a very limited view of the outside world. With their diesel engines roaring and weapons firing, the heat generated inside the tanks was oppressive. In battle, the noise, the smell of sweat, smoke, fear, and cordite can only be imagined. Not only is it a claustrophobic world, unbearably noisy and uncomfortably cramped, but the severely restricted view made it difficult to spot targets or to defend against enemy tank hunting teams.
The tank, which is battened down for battle condition, to see anything at all is extremely difficult, especially for the driver. He only got very low set slots to look out, and he can see very little. He has to rely on the commander to a great deal, who is sitting higher, and he got vision slots in his turret to look all around, and he could advise him if there's any trouble ahead.
In World War II, these tank hunting teams were trained to move up close to enemy tanks to disable them. Occasionally, they would climb onto vehicles themselves and set anti-tank mines or drop grenades into exhaust outlets and any open hatches. As it was designed to fire over long ranges, the main gun of the tank was useless at close quarters. To combat against infantrymen who got too near the vehicle, tanks were equipped with grenade dischargers, which could be operated from inside. Frequently, however, teams of infantry got close enough to climb onto the vehicles themselves. In those circumstances, the crew of the tank had to either clamber out and engage the enemy with small arms, or rely on supporting infantry and the other tanks in his unit to spray his vehicle with machine gun fire to kill any infantry clambering aboard. The turret of a tank is very much like a mobile pillbox, with only the minimal openings for weapons. The armor gives protection, but severely limits visibility. In desperate situations, there was a small opening called a pistol port.
There are several ways of defending yourself. Well, first of all, of course, if the infantry is silly enough to come from the front, you just run over them with your trucks. On the other hand, normally they would come from behind and from the side. And to defend yourself against approaching infantry from the side, you got a certain opening in your turret, which is known as a pistol port. You punch out a plug, which opens the hole, poke your pistol through or your machine gun, and open fire on either side. And that should keep them at bay. And of course, the early Russian tanks, for instance, also had a pistol port at the rear against approaching infantry from there.
tanks of all nations tended to mount at least 1 or 2 machine guns for close-quarter defence. Some tanks, in fact, mounted as many as 6. But in addition to these, smoke projectors, which could lay a smoke screen, mine layers, grenade launchers, and even light mortars could be built onto tanks for close-quarter protection against infantry or anti-tank gun crews.
The Germans used a cement-like paste called Zimmerid all over the sides of the vehicles that would be reachable by anyone attacking the tank, and its purpose was to stop magnetic mines being attached.
At longer ranges, there were other dangers. Concealed anti-tank guns were the chief menace. One well-placed shot could blast a tank to fragments. These guns were difficult to spot and could be camouflaged very easily. In order to give tanks protection against enemy guns, they need as much armor as possible. Ideally, every inch would be covered in thick steel plate. However, the crew need to be able to see out of a tank, so vision slits and hatches had to be allowed for. The engines need air intakes, and exhaust pipes need to allow the fumes to escape from the engine. These weakly armored parts of the tank are where it is most vulnerable, and they were the favorite aiming points for lurking anti-tank guns. From the confines of a tank, anti-tank guns were often impossible to find until it was too late. As the war progressed, the caliber and power of anti-tank guns increased from the relatively weak 37mm gun seen here, which was used in the first years of the war, to the awesome power of the high-velocity 88mm. The 88 was originally designed as an anti-aircraft gun, which needed to generate enormous power to fire a heavy shell thousands of feet into the air. When the German infantry discovered that this powerful gun could also be used to fire over a flat trajectory against tanks, a devastating new weapon was born. The massive velocity of its armor-piercing shells spelled death for thousands of Russian and Allied tanks during the years from 1939 to 1945.
The German 88, as we see here, was basically designed as an anti-aircraft gun. And during the early days of the war, they found out that it was very successful against pinpointed targets, bunkers and such alike, and of course against tanks. Direct sights were added, which you don't have on an anti-aircraft gun usually, were added, and several other changes done to the gun, and it turned out eventually to be just about the most successful tank and anti-tank gun there ever was.
Throughout the war, the 88 was the most feared adversary for all of the tank men in the Allied armies. The only drawback of this awesome weapon was that it was very cumbersome and needed to be towed into action. But once it was deployed in concealed and camouflaged positions, it was a deadly menace. Anti-tank guns were just one of the many hazards faced by the tank men. As the war progressed, all sides developed lightweight, portable anti-tank weapons of steadily increasing killing power. The Allies had the bazooka, and the Germans had the deadly Panzerfaust and Panzerschreck. These weapons were only effective at relatively short ranges, but they gave infantry teams a tank-killing capability, which made even the strongest tanks vulnerable. These German soldiers are stalking Allied tanks through a French village. They are ready to engage with their Panzerfausts. They first allow the leading Allied tanks to rumble past before carefully choosing their victim. The tank is destroyed. A huge investment in engineering, time and resources has been claimed by a single soldier with a simple weapon. Infantry anti-tank weapons worked on the principle of the hollow charge, which was designed to melt through the armor of the tanks and explode inside the vehicle. In order to defeat these weapons in Allied hands, the Germans found steel skirts would use up the energy of the missile in penetrating the steel outers, leaving the tank itself unharmed. They may have looked cumbersome, but they worked in practice and became standard issue for all medium tanks from 1943 onwards.
A lot of the German vehicles, especially later on in the war, as more powerful Allied tanks came about, had thin layered extra armour called Schürzen. This has the double advantage of maybe deflecting an armour-piercing round, but more particularly it would dissipate the power of a hollow charge shot. It hasn't got great velocity, so if it burns a hole in the side of an armour sheet that's outside the tank, it's very good protection for inside.
The 5-man crew was the standard for all German medium and heavy tanks. The crew of a Tiger consisted of the commander, who was in charge of the vehicle and selected targets. He also fired the turret machine gun. Next came the gunner, who sat next to the commander and targeted his enemies through his gun sights. In many respects, he was the most vital member of the crew. In battle, every shot had to count. The flight of a shell is affected by many factors, including wind direction, rain, snow, and other atmospheric conditions. The gunner had to gauge the range to the target, allow for any climatic factors, and compensate for the speed of any moving targets which were more difficult to hit. One miss could allow an enemy tank to get in the first vital shot, which spelled death in the tense tank duels of World War II.
The main 88mm armament of a Tiger was aimed and fired really as a result of a team effort. It was the job of all members of the Tiger's crew to use their vision devices to identify potential targets and to report them to the commander. The Tiger commander would then prioritise the target and would give orders to engage it. The gunner would traverse the Tiger's turret using a hydraulic system controlled by a foot pedal, and would then aim the gun using a binocular telescope sight, and would then fire the gun using an electrical ignition system.
The difference between tank guns of the Second World War and today is that frequently today's tank guns are stabilised so that as you're driving along you can fire as you go. The tank guns at the time wouldn't allow for that. You had to stop the tank, allowing yourself to be vulnerable to being shot at, and lay the gun on the target and fire.
Positioned on the opposite side of the turret from the gunner was the loader. He did the heavy manual work of loading the gun.
The loader was responsible for selecting the correct type of ammunition from the ammunition bins which were included in the Tiger's structure, and using an automatic or semi-automatic loading system to load the gun.
After each engagement, he also had the laborious job of emptying the shell cases and restocking the tank with the cumbersome rounds for the main gun. Inside the hull, towards the front of the vehicle, sat the driver. On his right was the radio operator, who fulfilled the vital communications function. He also manned the hull machine gun. The usual practice was for the crew of a tank to paint a white ring around the gun barrel for every enemy tank destroyed. Some crews were so successful in this practice that a thick white ring had to be painted, representing 10 kills. The most successful commanders proudly carried an array of kill rings like so many strutting peacocks. With the noise inside a tank, communication is very difficult. To communicate with other vehicles is almost impossible. The German engineers solved the problem by an internal intercom, which linked the crew and allowed them to communicate via headphones and microphones.
German practice at the time was to use a throat mic, which had two little microphones up against the side of your throat, and you would press those whenever you wanted to speak to the rest of the crew. If you then switched the radio set over, that also allowed you to broadcast to the rest of your unit. The headset has a pair of headphones on, so it muffles a little bit the sound of the engine, but it's a very, very loud engine anyway.
For communications between the tanks themselves, all German machines were equipped with radios. In the early war years, there were no such refinements on the Russian side.
In the T-34, strangely enough, as good as the tank was, even from its very beginning, the communication was very poor, because it had no radios, which is a normal way of doing things. The T-34 actually, the early ones, the commander had to get out of his turret at least halfway and wave two flags about, one red and one green one, I believe, and give signals like ships at high seas, you see. And that's how they changed directions or whatever he wanted them to do, which was very primitive, and it didn't work very well. It was only much later, for instance, the tank behind me, the T-34-85, the bigger one, had proper radio and radio contact within each crew member, and of course to headquarters as well.
The superior communications gave the Germans a great advantage, which compensated for their very real disadvantage in armor quality. During World War II, most German tanks started the conflict at a disadvantage. The puny 37mm gun was initially used to equip the Panzer IIIs, which were then Germany's main battle tanks. The same 37mm gun was also carried by all of the Czech-made 38T tanks, which, in 1940, were Germany's most numerous tanks. These guns were insufficient to penetrate at all but the shortest range, and even the upgrade to a 50mm gun, such as those carried by these Panzer IIIs, was still not really sufficient. Only the 75mm gun of the Panzer IV and Sturmgeschütz battalions were really suited to the demands of the modern battlefield. But even then, it had its limitations. The short barrel of the 75mm gave the shells only a limited velocity, which was effective against the thinly armored tanks of the early war years, but proved to be totally inadequate when the Germans met the superior Russian tanks during 1941.
The T-34 at its time was by far away the best tank the world had ever seen. It was absolutely second to none. The shape is followed even to this day, the outline of a tank. It was the mother, so to speak, of all modern tanks. It was just right in every respect. The gun, the armor, the speed, the lot.
To compensate for the low quality of the guns, the Germans further extended their technological lead by introducing special command tanks, which had the main guns removed to make room for additional radio equipment.
Command tanks are basically factory or battlefield conversions of ordinary gun tanks, which are used by relatively senior tank commanders, squadron, company, battalion or regiment commanders, to observe and to coordinate the actions of their subordinates on the battlefield. Command tanks generally mount extra radios, wireless sets for these purposes, and in order to incorporate these extra wireless sets and sometimes extra wireless operators, something usually has to be removed from the tank. Generally speaking, this is either ammunition, which is extremely bulky, or the main armament of the tank itself. Obviously, removing either, and particularly the latter, considerably disadvantages a command tank on the battlefield.
The cohesion which came from a smooth flow of commands was one of the obvious reasons that the inferior German tanks of 1941 and 1942 were able to overcome the superior T-34s and KV-1s. These command tanks soon drew special attention, and attempts were made to disguise them with dummy guns.
A command tank is frequently without a main gun, so that it was made to look a little bit like the appropriate tank with a length of wood or pipe.
Even where a dummy gun was used, however, usually the extra wireless antennae, which were installed on the tank to make the extra wireless sets work effectively, were another way with which the enemy could identify enemy command tanks and knock them out.
This disconcerting factor was not mitigated by the rigid German practice of numbering their tanks in sequence, starting with the commander's vehicle, which frequently carried the number 001 displayed prominently on the turret, a sure invitation to enemy gunners. By 1943, a command vehicle was no place to be. Infantry had, by now, developed extra killing power in the form of magnetic mines, bazookas, and the Panzerfausts. These deadly weapons could all blast through the armor of a tank, but the Russians found that the simple expedient of a bottle filled with petrol, lighted, and thrown onto the engine decks could disable even the largest tanks. Their tank hunting teams soon became very adept at wielding this single, improvised tank-killing device. The tanks, which the Russians stalked so effectively, were designed to do two jobs on the battlefield. The first was to engage and destroy other tanks. The second was to attack infantry and artillery targets. In essence, the successful engagement and destruction of enemy tanks was a matter of the simple application of brute force. Elementary physics tells us that force equals mass times velocity. For the job of destroying other tanks, the tank needs to be able to fire the heaviest practicable shell at huge speeds. This produces enough force to punch through the armor of an enemy tank. Explosive power alone has little value against the thick armor of a tank. What gives the missile its penetrating power is the enormous velocity which punches through the armor of enemy vehicles.
Armor-piercing rounds, very simply, tend generally to be solid shot, by which I mean a shell which is essentially metal with a very small explosive charge, and which relies upon a very high velocity and the enormous pressures and heat created by a round impacting on armour in order to burn their way or melt their way through the armour of, say, a turret or a tank generally, and to splatter around inside, either destroying equipment or killing or injuring the crew.
Very occasionally, it was found that armor-piercing shells were traveling so fast they passed straight through enemy tanks and through the other side, without damaging the vehicle or its occupants. A variety of high-explosive anti-tank rounds were therefore developed, which were designed to first penetrate the armor of an enemy tank, then explode inside the vehicle. This fine balancing act was rarely achieved in practice, and it is debatable whether the small amount of explosive contained in the shells was much more effective than the massive kinetic impact of a high-velocity round. Against infantry and field guns, the tank needs to be able to fire a high explosive round. Here, the speed of the shell is less important. What matters is the weight of explosive packed into the warhead. The bigger the shell, the bigger the explosion. To reach over walls and intervening obstacles, a plunging trajectory is the best method of attack against infantry hiding behind obstacles in buildings and trenches.
High explosive shells, generally speaking, have a hollow cone and into which high explosives is inserted. And the point of these is to detonate and to throw out a lethal stream of metal splinters, which are particularly useful against infantry out in the open. Of course, high explosives are also useful for destroying non-armoured targets because of their explosive force.
With the space taken up by the main gun, the crew and the engines, there is surprisingly little room in a tank for the ammunition, which was vital to survival on the battlefield. Most tanks could hold enough shells for around 90 shots, tightly packed into every conceivable space. Most commanders favored a mix of 40% high explosive and 60% armor piercing. But it was often a matter of a personal assessment of the likeliest target to be faced on a given mission. Getting the balance right was a crucial decision. Armor-piercing rounds were useless against infantry, and high explosive would not penetrate tank armor. Having a large stock of the wrong kind of ammunition effectively left the tank impotent. These anti-tank gunners are attempting to clear infantry from a building without the benefit of high explosive rounds. In slow motion, we can see the straight trajectory and high speed of the shell, but the effect on the building is minimal. A high explosive round would have been devastating. In battle, many experienced crews could fire one round every 5 seconds. So not surprisingly, ammunition supplies could quickly become exhausted, rendering the tank helpless. At this delicate juncture, the tank commander was faced with a crucial choice. Either leave the field to rearm and refuel, or await resupply in the field. The bulky tank ammunition could not be transported on foot, and required a vehicle to resupply the tanks. Trucks were too vulnerable to be sent into the fighting area, so the Germans developed a special turretless tank called a munition schlepper to carry out the dangerous job of ammunition resupply on the battlefield. To ensure that ammunition supplies were used wisely, German tanks were forbidden from firing on the move. The prescribed tactic was to strictly engage enemy targets from a static position. This made aiming much easier, giving the gunner the best chance as he lined up his target on the middle triangle of his gun sight. To help him in his task of judging the flight of his shells, they were equipped with a tracer element, which produced a trail of bright light to help pinpoint the path of the shell as it flew towards its target. The tank crews prayed that their first shot would hit, turning the enemy vehicle into a flaming mass as the fuel and ammunition exploded. A miss could mean their own destruction by return. The prospect of the awful death of men trapped in a burning tank haunted the tank crews. It was a nightmare prospect which dogged their every moment. In all of the major tank battles of World War II, from Poland through North Africa and into Russia, the black columns of smoke from burning vehicles can be seen hanging on the horizon like gathering storm clouds. All too often, they marked the funeral pyres for their hapless crews. Death or injury could come to the tank crews from a myriad of sources. It was not always necessary to even damage the vehicle. One other ever-present danger for tank crews were metal splinters caused by hits on the outside of a tank. As the outside velocity of the impact was converted into violent internal energy, these deadly fragments were blown from the inside of the turret, where they would fly around the inside of the tank, slicing through the bodies of the crewmen packed together in their claustrophobic world. In many early tanks, such as these 38T Czech tanks in German service, there was a further danger. The rivets used in the construction of the tanks were particularly dangerous. The violence of a hit on the outside of the tank would cause the heads of the rivets to ricochet around inside the vehicle. This was also a major problem for the British tanks of the early years, which were also of riveted construction rather than cast steel. And many horrific injuries were caused by flying rivets from shots which had not actually penetrated the tank. Another ever-present danger for tanks was less spectacular, but equally deadly. Anti-tank mines could be placed in great numbers to protect a defensive position. These mines would support the weight of a man without detonating, so infantry teams often passed by unsuspecting. But as soon as the weight of a tank was present, it exploded with tremendous force. Although tanks were sometimes destroyed by mines, the most frequent result was that they lost a track. This resulted in crews having to leave their vehicle to attempt to repair these massive iron tracks in the heat of battle. The job of testing for mines and clearing a path through them was the job of the pioneer sections. Occasionally, this ritual task was overlooked. At the vital Battle of Kursk, General Heinz Guderian, the inspector of armor in the German army at the time of the crucial battle, was left livid with rage. His new Tiger tanks had rolled into action through uncleared minefields, with the result that many of his most effective machines, the spearhead of the army, were rendered immobile by a threat which could easily have been anticipated and cleared. As the war continued, each surviving tank in the German panzer divisions became an increasingly valuable asset. As battlefield losses rose, the war-ravaged German factories, which were being pounded day and night by Allied bombers, could no longer keep increasing the supply of war vehicles to match those destroyed. Although production rose year on year, during the crucial years of 1943 and 1944, losses of tanks rose even faster. But provided it wasn't actually blown apart or completely gutted by fire, many battle-damaged tanks could actually be repaired and brought back into service. For the Allies, with their limitless supplies of men and material, this was a less pressing issue. But for the Germans, it was a vital matter. It was a source of great frustration to many German tank crews that Hitler himself placed a priority on the production of new tanks over the supply of replacement parts and engines. In many cases, old tanks could easily have been brought back into service at the front line with a regular supply of spare parts and engines. This would have been easier and more efficient than manufacturing, then shipping a complete new tank all the way from Germany. In the Desert War, Rommel's tenuous supply line was even more difficult. It became essential to recover as many damaged or broken down vehicles as possible. While this was also a factor in British thinking, it was a less pressing issue as the 8th Army was comparatively well served with replacements. Control of the field after the battle was vital for Rommel. It allowed the Afrika Korps to salvage Allied and enemy machines alike.
Controlling the battlefield after a tank battle is finished is vital for either side. The chief reason for this is that most of your vehicle casualties are recoverable. If you've got a small hole through the middle of your tank, it's usually made a mess of whatever's inside, but the more common type of tank casualty would be a missing track link, damaged tracks, damaged suspension that's prevented the tank from moving. Most of those tanks very easily recoverable with just half an hour's work.
In Russia, it was becoming equally vital for the Germans to keep control of the battlefield after an engagement. The mechanically simple Russian T-34s could often be salvaged. German crews, like these, frequently drove captured T-34 tanks into action. During the course of the war, 40,000 T-34 tanks were manufactured, more than double the capacity of the entire German tank industry. By 1943, in Russia, as in North Africa, it had become an overriding necessity for the Germans to retain control of the battlefield. Otherwise, tank losses could never be made up. With the huge weight of the later war tanks, such as these Tigers, immobilized tanks could often only be moved by the power of another Tiger. The heaviest tractor in the German army was the 18-ton F3, but it took 3 of these harnessed together to move one broken-down Tiger. And in the midst of the battlefield, the tractors were highly vulnerable to anti-tank rounds, high-explosive shells, and the handheld weapons of the infantry.
Tiger tanks, which each weighed about 60 tons and which were prone to a range of mechanical and electrical failures, certainly suffered from problems. In addition, they were extremely expensive, valuable assets that could not afford to be wasted. Because of this, recovering Tiger tanks was particularly important if they were knocked out. There were a range of options available to the SS and the Army tank battalions which operated Tigers. Most obviously, they could use their own gun tanks to tow other tanks out of trouble. The problem was this, that it tended to cause electrical or engine or transmission malfunctions in the Tigers doing the towing. Alternatively, unarmoured half-tracks could be used, but unfortunately several of these needed to be used to tow a single Tiger, and because they were unarmoured, they were vulnerable on the battlefield. Quite clearly what one required was an armoured recovery vehicle that could tow a Tiger on its own, and which was capable of operating in intense combat conditions.
Once again, the solution to the problem was to develop a specialist recovery vehicle, known as a Bergenpanzer. These machines dispensed with the turret and replaced it with a box-like wooden structure. They were designed to run quickly up to disabled tanks and tow them away from enemy reach. Every tank carried heavy towing cables, ready to be hitched up to a recovery vehicle or a friendly tank. Most sensible commanders went into action with their cables already hooked up, just in case. Tanks look incredibly robust, but in many respects, they are surprisingly vulnerable. They require high maintenance and are prone to break down. They also shed their caterpillar tracks with infuriating regularity, especially in thick mud, when crossing obstacles or as a result of anti-tank fire and minefields.
The tank tracks, as you might guess, are the most important parts on a tank really to get you along. And they have to be changed. For instance, if one link just breaks, one pin has to break, and you haven't got a track anymore. Or enemy action, tracks are often hit by enemy shells, damaged, and have to be changed eventually. It's a very hard job and takes a lot of effort to do it. The whole crew is involved. And how I've never done it myself on the enemy action, but I shudder to think what it would take.
These German tank men, rushing to replace a heavy track in the thick of the action, had ample opportunity to curse their ill luck. But it was an all too commonplace event. Despite the myriad of dangers, the tank was the queen of the battlefield in the wide open spaces of North Africa and Russia. In the first 4 months of the war, the Germans discovered that there was one environment in which tanks should never be deployed: the built-up areas of towns and cities. There, they became especially vulnerable to lurking infantry and anti-tank guns. The Germans learned this lesson as early as the Polish campaign of 1939, in the Battle for Warsaw. But despite all of their previous experiences, these mistakes were repeated at Stalingrad, Kursk, and in Normandy. some commanders continued to commit tanks in towns right up to 1945. In 1944, these destroyed German tanks littered the streets of Villers-Bocage. They were destroyed by concealed British anti-tank guns when they grew too confident and rolled into the town after a period of conspicuous success in the open fields around the town. This page from the 1945 US Handbook on the German Army illustrates how this massive Jagdtiger tank destroyer, unwisely deployed in a town, was destroyed by the simple expedient of a Molotov cocktail dropped from the upper window into the open hatch of the tank below. But it was not just the Germans who suffered. Even the mightiest giant, it seemed, had its limitations. In the last month of the war, this lone soldier sets out to destroy a Russian tank. His smile suggests elation and pride. Or maybe it's just the relief that he has survived, and soon it will all be over.